The fundamental forces are the interactions that do not appear to be reducible to more basic interactions. There are four fundamental forces known to exist. The gravitation and the electromagnetic can be seen in everyday life, while strong and weak nuclear forces cannot be seen. Each of the known fundamental interactions can be described as a field.
The gravitational force is the mutual force of attraction between particles of matter. We call the gravitational force attractive because it always tries to pull the masses together, never pushes them apart. In fact, every object, including you, is pulling on every other object in the entire universe. This is called Newton's universal law of gravitation. The formula for calculating gravitational force is shown on examples of gravitational force. Some objects have much more gravity than others. The Earth, for example, has more gravity than people. This is why an object that falls is drawn to the Earth and returns to the Earth, instead of being drawn to a person and flying on that person. Some examples of the force of gravity include the force that holds the gases in the sun, the force that propels the tumbler down the slide. The electromagnetic force is the force that occurs between electrically charged particles, such as electrons, and is described in electrostatics as being either positive or negative. Objects with the opposite charges produces an attractive force between them, while objects with the same charge produce a repulsive force. Therefore, we have the greater the charge, the greater the force, and the greater the distance between the charged objects. Examples of the electromagnetic force. All of the light from the sun and other sources consists of photons, which are the electromagnetic force carriers, magnets, and the Earth's magnetic field, which protects us from harmful radiation or aspects from the magnetic force. Gamma radiation is an electromagnetic mechanism which allows an atomic nucleus to lose energy.
In particle physics, the weak interaction, which is often called the weak force or weak nuclear force, is a mechanism of interaction between subatomic particles that is responsible for the radioactive decay of atoms. The weak interaction serves as an essential role in nuclear fission. The effective range of the weak force is limited to the subatomic distances and is less than the diameter of a proton. An example of a weak nuclear force. As the picture from the previous slide showed, lithium into beryllium, the radioactive beta decay is due to the weak interaction, which transforms a neutron into a proton and an electron. The strong interaction is observable at ranges and mediated by two force carriers. On a larger scale, it is the force that binds proton and neutron nucleons together to form the nucleus of an atom. On a smaller scale, it is the force that holds quarks, elementary particle and fundamental particle of matter, together to form protons, neutrons, hadrons, subatomic particle, and other particles. In the latter context, it is often known as the Keeler force. An example of a strong nuclear force. The nucleus of a helium atom, the two protons have the same charge, but still stay together due to the extra nuclear force from the neutrons.
Thank you so much for watching the video. We hope you enjoyed this presentation, and as always, we'll see you next time.